In this lecture we are going to talk about searching algorithms. And the purpose of search is to check for an element or to retrieve an element from any data structure where it is stored. The searching algorithms can be classified into two main groups. First is the sequential search. In this type of algorithms, list or array is traversed sequentially and every element is checked. The second group of algorithms is the interval search. These algorithms are specifically designed for searching in sorted data structures. This type of algorithms repeatedly target the center of the search structure and divide the search space in half. Therefore, these algorithms are much more efficient than sequential search. Let's solve some problems in order to show how different search algorithms work. We will search for a particular number in an array of integers. Our function must return index of the element if this element is in an array, otherwise it must return -1. First we will implement the linear search, which belongs to the group of the sequential search algorithms. Let's say we have a sorted array and we want to find number 17 in the array by applying a linear search. In order to do that, we simply traverse the array linearly until we find the right element. We have found the element we have been searching for and we have returned its index, which is 9. It is obvious that the time complexity of this algorithm is O(n). Now let's solve the same problem using binary search, which is one of the most popular algorithms of the interval search. We have a recursive implementation of binary search. Let's talk about how it works. We take the middle index of stored array and check if it's the right element. If so, we return the index of this element. If not, we check if the middle element is greater than the element we are searching for. If condition is satisfied, we can split the sorted array in half and recursively search for the element on the left side of the divided array. If the condition is satisfied, we carry out the recursive search on the right side of the divided array. Let's visualize this process. We will search for number 17 in this sorted array. We take the middle index and check if element at this index is the one we have been searching for. It is not the element we are searching for. So now we check whether the middle element is greater than the element we are searching for. The 12 is less than 17, so it means we'll continue our search on the right side of the divided array. The left side of the array is no longer relevant to our search since we know that the element we have been searching for is greater than 12. We carry out the search in the same manner on the right side of the array. First we take the middle element of this part of the array. We see that the element we search for is less than the middle element. It means we need to go to the left side of the array and carry out our search. Again, we take the middle element and now we see that this is the element we have been searching for. So we can return its index, which is equal to 9. At each step we cut our space in half. It means that the time complexity of this type of search is O log n. The key points of this lecture would be the following. There are two main groups of search algorithms: sequential search and interval search. In the sequential search, list or array is traversed sequentially and every element is checked. This type of search algorithms has the O(n) time complexity. In the interval search, algorithms are specifically designed for searching in sorted data structures. This type of algorithms repeatedly target the center of search structure and divide the search space in half. Therefore, these algorithms are much more efficient than the sequential search. Usually, interval search algorithms have O log n time complexity. Thank you for your attention.